In the previous video, we outlined all the major solutions to the Fermi Paradox. If you haven't watched that yet, this video is meant as a standalone, but it would probably help to watch that first. As a reminder, the Fermi Paradox is the apparent contradiction between the seemingly high probability of alien civilizations existing and the total absence of any solid evidence that they do exist. Or as Enrico Fermi put it, if there are tons of alien civilizations, where is everybody? We outlined a lot of the proposed solutions in that video, from us just not knowing what to look for to find them, to them going out of their way to hide themselves from us, or us just refusing to believe evidence right under our noses of their existence. However, one of the more popular solutions revolves around the idea that alien civilizations are terribly uncommon, either because they rarely develop civilization in the first place, or because they almost always go extinct shortly after becoming technological civilizations. Today, we'll be looking at the latter option. If you're alive today, in the 21st century, and you're watching YouTube, then you've already been exposed to virtually every apocalyptic scenario imaginable. Hollywood does a wonderful job blowing stuff up for our entertainment. We are going to go over some of these and see how realistic they are. But we're not interested in some of these cases because they don't really matter in terms of the Fermi Paradox. For instance, the portrayal of genetic supermen wiping out mankind is really an irrelevancy as far as the Fermi Paradox is concerned, because a highly aggressive race of genetic supermen are just as likely to go out expanding the wider universe as we are. Doomsday for humanity that replaces us with intelligence that has survival and propagation motives doesn't really matter to the Fermi Paradox. As we previously discussed in the Dyson Dilemma video, even a singular intelligence, which didn't want to reproduce, has good motives to expand itself. We're looking for something that ends civilization, not civilization as we know it, but just destroys any intelligence with the desire and capacity for expanding into space. So for instance, a swarm of self-replicating robots with the technology for interstellar travel, but nothing approaching a civilization, is a concern in the Fermi Paradox. Alternatively, a complex and ancient civilization which arose after a nuclear war and just bans any 20th century technology and enforces those bans rigorously is not. One could argue the latter case, though, that anyone who bans technology because of some cataclysmic event is going to have some problems enforcing that over very long periods of time. Societies mutate on a generational basis, and especially without a solid worldwide communication system, you'd expect to see a lot of schism and fracturing. Even keeping an orthodoxy for just a few generations is very hard. But planets exist for billions of years, and the simple fact is, all things being equal, a group which starts ignoring those technological bans are going to start gaining a massive economic and military edge, which is going to prevent anyone from enforcing them on them. So we're going to go over a lot of these doomsday scenarios, and we'll be discussing not so much how likely they are to occur individually, but how likely they are to take a civilization down entirely. Just wipe a civilization out for keeps. It's hard to really classify civilization-destroying events, but we are going to give it a go. Here's the ones I've selected for today. Nuclear warfare, bioterrorism, post-apocalyptic attrition, cyclical apocalypses, climate change, artificial intelligence, grey goo, antimatter, suicide pact technologies, and mind control. One thing we'll be mostly avoiding is social matters. Not only are these hard to predict, and as we point out, prone to very rapid change on stellar timelines, but they get pretty controversial because they get political. Everyone's mileage varies on such things, and there's not really a rigorous approach available for us to be able to analyze them in detail. So we just leave it be. The comment section on the video, that way it doesn't get full of invective. By the way, I do read all the comments on these videos, and I do try to reply to them, so please feel free to leave a comment below. So, nuclear war. This is one we're all pretty familiar with, but like a lot of disasters in movies, it tends not to get portrayed very accurately. Nuclear bombs are devastating, but fundamentally, even at the height of the Cold War, there just weren't enough nuclear bombs to kill off a civilization for keeps. Nuclear bombs kill many people, they'll collapse a present society, and they leave long-lasting damage to the ecosystem. However, they don't get everybody, and in most estimates they don't even get half. Starvation and chaos will get far more, but ironically are less of a threat the more people die initially. We'll cover this more in the post-apocalyptic attrition segment, but it basically boils down to having some surviving settlements that eke their way through the centuries it takes for the planet to recover. Fundamentally, just as with our own Dark Ages, these periods simply are very short compared to the time span that planets exist for. If some world has beat us to modern civilization by a mere million years, that's an eye blink of time compared to the age of the universe. Even if it took them thousands of years to recover from a nuclear war, and even if they repeated the process several times before learning better, or before running out of uranium, they'd still have only burned up a small percentage of their head start on us. Now, a sufficiently large nuclear device or nuclear arsenal could kill everyone. We can't rule this out, but there's a host of hurdles to building an arsenal that's just that big. In order to build a stockpile that's many times larger than what you'd ever need to win, you have to be willing to pay for them, and they're very expensive to build and maintain. And they also amount to what's basically called a dead man switch. The purpose of a bomb that big, one that can just completely blow up the entire planet, so to speak, or make it totally unlivable for life, is to convince an enemy that attacking you is suicide. People are very interested in their own safety, though, and their own survival, so they will tend to build such things in with massive safeguards, and they also tend to object to being built in the first place. We've never built one, right? Odds are very good not everybody else did. And the Fermi Paradox, all that really matters is those odds. If one species does this but 9 others don't, it doesn't really matter. And even if 9 species did this and 1 didn't, then that 1 is all that matters, because it only takes 1. So fundamentally, nuclear war, at least with the technology we've devised thus far, isn't a terribly good Fermi Paradox solution. So what about biowarfare? The same conditions apply to any virus that doesn't get everyone, but we can't rule out someone designing a virus that does get every single person. And it really does need to get every single person. If even 1 in a million are immune to the tail of disease, that still leaves thousands of people alive. They'd be scattered all over the place, but since vast amounts of technology and resources would be kicking around intact, it would only be a matter of time before lonely people started making efforts to link up with each other. When those people have months or even years to contemplate the problem, they don't need to be geniuses to think that they could use radio towers to broadcast to others, or even just get on top of a skyscraper and light a signal beacon afire. And that's assuming no one had enough time during the crisis to start taking measures like telling the survivors how to link up or getting people into sealed environments with resource stockpiles. And if the immunity wasn't 1 in a million, but was more like 1%, you wouldn't even need special measures to link people up into groups big enough to survive and breed, because your average metropolis would have thousands of people left over just in it. So it would have to be a 100% kill. And that's not really a natural or accidental lab accident kind of thing. You almost have to have a large and well-funded group set out to intentionally kill every single person on the planet. Outside of Hollywood, that's not a terribly tenable scenario. The bigger the group, the better the odds of someone changing their mind and informing the authorities. Even if we grant all of that, though, we still have 3 problems in the context of the Fermi Paradox. First, not every alien species is likely to do this. Just like with nuclear war, it doesn't matter if it's 1 in 10 that does and 9 in 10 that don't, or even if it's 9 in 10 that don't, or even if 99% of all alien species did this, it still wouldn't really matter much to the Fermi Paradox. If you have thousands of civilizations arising in a galaxy over the course of a billion-year period, it doesn't matter if 99% of them kill themselves off. If 1% of them does continue on, you've got the galaxy just swarmed over with civilizations in a very short period of time, and you have all the other galaxies too. Second, when we're in the context of intelligence developing fairly commonly, then wiping itself out, which is what the doomsday approach to the Fermi Paradox revolves around. Wiping out all humans with a virus would still leave other intelligent mammals around who would, if intelligence evolves commonly, just come and replace us. It might take 1,000,000 years, or 10 million years, or even 100 million years, but even 100 million years isn't that long compared to the age of the universe or this planet. It's around 1%. Third, we have to remember that viruses might not really be a universal threat. Viruses are present in, and a threat to, every environment and organism on Earth. But that doesn't mean they'd be an automatic threat in all life-bearing worlds to the degree they are to us. A given species might just have much more effective immune systems, or a biology which is very toughened against dying from infection. So this type of apocalypse isn't really a good Fermi Paradox solution. This takes us to the post-apocalyptic attrition option, which is less of a specific apocalypse and more about the recovery of a civilization after it falls. One common theme of disasters is that you often get more damage done in the aftermath than the actual incident itself. In fiction in particular, we'll have riding mobs or in the aftermath roving brigands who basically steal to live and destroy any stable bastions of civilization they encounter. This results in steady attrition just pushing us down till no one is left alive. Now the problem here is you can only kill so many people before theft to live is no longer viable. Once your numbers get down to hunter-gatherer levels, a few square miles per person, it is now not only no longer necessary to kill people to get food, but it also becomes a bad strategy. Deer won't shoot you. If that's all that's left of civilization are people who'd survived the bloodbath up until that point, odds are good those survivors can and will shoot you. You've also got the problem that an organized and disciplined group that's been keeping around people who have other values besides fighting, like the ability to repair machinery or treat injuries, is going to just butcher the stereotypical post-apocalyptic Mad Max tribe of techno-savages in any sort of conflict. So eventually attrition slows down, and it's basically bound to do this while the numbers are still high enough that people can still regularly encounter each other. So you really can't push a population down below breeding level viability through attrition. After a while, even if they've lost all their technology, and especially if they've lost it all, they just revert to being hunter-gatherer tribes. A setback, but presumably of thousands of years at most. And it would probably be a lot less because examples of technology, rusty or not, are going to be lying around everywhere, and you can fit pretty much every major bit of science and technology up to the 20th century into books that would take up just a small trunk or chest. Heck, you can download the entire Wikipedia database free of charge onto a single thumb drive. But you'd be bound to have caches set aside by people of this variety, and even if you didn't, you don't need to be nearly as smart as the guys who designed the internal combustion engine to be able to reverse engineer it from some rusty remnant. Our own buried landfills, unlikely to be pillaged in an apocalyptic aftermath, would contain everything you needed. So you would expect civilization to recover eventually, and sooner than later probably. In any doomsday which left enough for us alive to breed and left the world still ecologically intact enough to support life. But having killed themselves once, what's stopping them from doing it again? Cyclical apocalypses, natural or unnatural, are a real concern. We've got some great examples of this in fiction, and of course these being fiction tend to either focus on breaking this recurring cycle of doomsdays, or if on the bleaker and darker side, on the futility of trying to break out of these cycles. But how probable is this? And of course that's really hard to say. If a civilization arises, nukes itself nearly out of existence, recovers over thousands of years, and then does it again, what's to stop them from doing it again? And again, and again. Well, I mentioned half-jokingly earlier that you'd eventually run out of enriched uranium to build nukes with. Radioactive isotopes decay with time. That's why they're rare to begin with. There's just not that much of them left over from the ancient supernova that spawned them. And if you're being on these cycles where you're just mining the stuff up, building nukes out of it, and nuking yourselves, you're going to run out of uranium eventually. And sooner than later, because there actually tends not to be that much of it. But fundamentally, it's really hard to eliminate all traces of a civilization. Even if every single historical account is burned or bastardized into mythology that barely resembles what really happened, you're going to start having increasing amounts of archaeological and even geological evidence. It would be hard to miss evidence that every 10,000 or so years for the last couple million years, the civilization has gotten technological, then knocked itself back to primitive hunter-gatherer remnants. And even that's a pretty unrealistic scenario. We really do have bunker archives, even back to the crypt of civilization that was built in Georgia in 1936, which would be usable guides for a forging civilization even thousands of years after they were built. These sorts of time capsules and caches probably would survive almost any doomsday scenario that left people alive. If you're a pessimist, you can come up with ways these might fail to survive or just be disbelieved, but intelligent critters are usually very survival-oriented, and it's hard for me, personally, to imagine such cycles just going on and on and on, uninterrupted for thousands of cycles, even with the evidence there that these will happen, that they could just keep going for these thousands of cycles, all the way until the world got burned up by its own sun. Our next one is climate change. This is politically controversial, so we're going to keep this short. Like I said, I'd like people to leave me comments on these videos, but I don't invite invective. Please take any pro or anti-climate change arguments elsewhere. There's so many other forums and videos that discuss that in detail. Here we're just going to assume that it's possible, and its aspect is actually very straightforward for our purposes. It is possible climate change could leave a world dead, rendered either as a snowball Earth that stays forever locked up as an ice ball, or in a runaway greenhouse effect like we have on Venus. We don't know if those two extremes are actually possible for Earth, but they are certainly a scenario that has to be considered. If this is possible, then should either take place, then everybody's dead. And it's a pretty decent Fermi Paradox option. Except that it would require every species lets this happen, and that's counterindicated because even if they all would, it's not actually a given that they all could. All fossil fuels are the product of a very long and complex series of biological and geological processes. Underwater oil deposits often rupture and leak out into the ocean. Underground coal seams can catch fire and burn. So there's really nothing saying every world would have as much of these items as we do when technological life arose. They might have almost none. And they might be immune to the problem because they just don't have that much. Plus, very big factors in play on this would be the configuration of the planet itself. How distant is it from its own sun? What type of sun is it? What is its own default atmosphere? And many, many other factors. They might live on a world with a dozen times more atmospheric carbon than we already do, and what's left is what's actually keeping that planet warm enough to live on in the first place. Or their world might be very prone to earthquakes compared to us, and all those easy deposits of fuel that we rely on for them ruptured and dissolved long before they ever came into existence. Add to that, if it doesn't actually wipe out all life but eventually recovers, then the civilization would recover and wouldn't have those deposits for technology the next time around. That's the problem because we didn't get to our current technological state without being able to use those. But we did have renewable fuels to use before these, like alcohol, ethanol, and firewood, and so on. You cannot support as many people in the short term, and the fuel is more expensive, but this probably would just slow technological process, not halt it. And again, centuries or even tens of thousands of years just mean nothing in the timeline of the universe. So this also isn't a good Fermi Paradox solution. Our next one, artificial intelligence, is itself also not a really good Fermi Paradox solution. As we mentioned earlier and in previous videos, replacing one intelligent species with another really doesn't mean anything to the Fermi Paradox unless that new species or new singular intelligence has motives that are just so different that they don't even correspond to what we would expect as basically the natural rules for life, that it is very focused on surviving, that it wants to reproduce, and that it wants to expand its resources and territories. An artificial intelligence which didn't care about its own survival just isn't likely to replace the species that created it in the first place. And we discussed in the Dyson Dilemma video why even one which didn't really want to reproduce would still functionally emulate an expanding and growing species as it tried to gather in more resources. So artificial intelligence really only matters in the sense of being an apocalypse which kills it and us, a mutual kill. The big problem with this is that an AI which is smaller than us, a strong AI, it's smarter than us. In Hollywood, these AIs run numbers quickly, but are genuinely absolute morons when it comes to social interaction. We get creeped out from them and scared away, right? A real strong AI probably isn't going to scare us because it will be smart enough to emulate a very pleasant, helpful, and non-threatening friend. Real artificial intelligence planning to take over the world is probably going to be a lot more likely to go to the courts for public opinion and the legal courts and convince them that it should be treated as a person legally. And then it's going to talk to people and convince them to vote it in as president in some landslide election, as opposed to going all Skynet or Matrix on us. If it wants us all dead, we probably never know it till it acted, and the outcome would probably be about as predetermined as fighting off an interstellar invasion by a species set on genocide and capable of interstellar travel. And what I mean there by a battle with alien species is that the battle would last about 10 minutes, which is to say, you just don't beat a smarter, bigger, and more technologically advanced group in a one-on-one fight unless its goal isn't to kill you in the first place. If it just wants you dead and doesn't care about property damage, an interstellar ship doesn't even need to fire any guns. It just has to jettison some of its mass aimed at Earth before it starts slowing down. Because a few thousand tons of garbage moving at relativistic speeds and hitting Earth would make a nuclear war look like a ballroom scuffle in comparison. And a machine doesn't need an intact biosphere to live, so it can go all scorched Earth as well. It's hard to beat an enemy who is smarter than you and has a much freer hand where collateral damage is concerned. So it's really unlikely a fight with a machine mind would end in a mutual kill, and the survivor, whether it was them or us, would pick itself up and recover, so it's not a good Fermi Paradox option. Alternatively, a stupid machine is. Grey Goo, as it's often called, microscopic little machines which are simply programmed to tear everything apart to make more of themselves, is an apocalypse scenario which fits in the Fermi Paradox, though only if they're too dumb to make it off-world. This is a lot like the Biowarfare option, only far worse because there's no immunity to being disassembled as scrap material by a billion little robots who also disassemble all the animals, vegetables, and minerals. So Grey Goo is a real concern in the Fermi Paradox. Two caveats in context of the Fermi Paradox, though. First, there's no reason to assume that even if Grey Goo starts off mindless, that it would also stay mindless. We, ourselves, are essentially descended from Grey Goo. Early life just mindlessly ate everything it could to reproduce. It mutated and grew in complexity. Grey Goo would also likely be capable of mutation. It is basically unavoidable in any kind of replicating life or machine that it should be unable to mutate. Now, Grey Goo reproduces a lot faster than biological life. If it didn't, it wouldn't be a threat. So it might climb the evolutionary chain to intelligence much faster than biological life did. Of course, it might also be exponentially less prone to mutation, so that might cause a reverse. But from a certain light, Grey Goo is just a life reset akin to when oxygen breathers became the norm for life a couple billion years ago. The other caveat is that self-replicating machines are probably not the boogeyman we make them out to be. Just because something can replicate faster than biological life doesn't mean it can replicate absurdly faster. There's a waste heat involved in any mechanical process. As an example, if you take a metal coat hanger and you bend it back and forth several times quickly till it breaks, and then you stick your finger at the place where it broke, you'll burn your finger. There's a lot of heat in that process. They'd be limited to how fast they could rip stuff apart without melting themselves. Second, you're probably aware that electronic devices are sensitive to what we call an EMP burst. You can harden electronics against this, but only to a point. This is even more the case with tiny machines. When you start adding in all that shielding, it's just going to slow down its ability to reproduce because now it needs more resources for each machine. It needs more energy just to run itself, and it needs more time to make those machines. And fewer of them can actually cluster while they're busy trying to disassemble something. Plus, if they're dumb, you can fight them. If they're smart, then they're probably wired together or much larger, and at that point they become a group consciousness or smart individual species, and then they are not a Fermi Paradox solution anymore. If it's smart, it doesn't qualify as a Fermi Paradox solution because that's again just replacing intelligent life with another type of intelligent life. It incidentally would also make them sensitive to signal jamming if they were communicating together like that. So you probably can't end the world from someone just accidentally, walking down the street with a vial of, nano machines dropping on the concrete and then swarming to dissolve all the cities. You could even just nuke them in a case like that. Nukes beat matter every time. Nuclear force and energies are just orders of magnitude more powerful than chemical bonds that bind matter. And this actually takes us into our next one. If there's one thing that's even nastier than nuclear bombs in terms of destructive potential, it's antimatter. A baseball-sized and massive antimatter drops to the ground would go off with a destructive blast on par with the largest nuclear devices we've ever made. Just a baseball's worth of it. They release all their mass energy, whereas nukes release not even a percentage point of theirs. This is exactly what makes interstellar ships so dangerous and why hard science fiction fans often chuckle at the notion of an unarmed ship. Anything going out at those kind of speeds is worth more than its weight in nukes in terms of its destructive power and potential, because the energies involved in those kind of speeds parallel mass energy, that E equals mc squared that Einstein is so famous for, and exactly what antimatter has in terms of its own energy. You could blow up a fair-sized city with just the antimatter that would fit inside a ballpoint pen's interior, and you could blow up that same city just by having your pen or hammer fall off on the side of a spaceship if you're outside on the airlock working on some damage and your hammer goes spinning off in the void and hits a planet, boom. Of course, if you have easy access to antimatter, you basically do have access to the ability to travel with the interstellar vessel. That's the kind of energy ranges needed to move these things to the point that they can get to another star in a human lifetime. So how does this fit into the Fermi Paradox? The whole point is concerning technologies that would prevent somebody from traveling to other stars. And where antimatter is concerned, the reason it is a Fermi Paradox worry is because it might be really easy to manufacture the stuff. It might be very easy to hide the stuff or store it. Right now, antimatter is very hard to make. As powerful as it is in just a single gram, just a pea-sized mass of stuff, which is on par with a Hiroshima bomb, as powerful as that is, it is so hard to make that it would take us 1 billion years just to make that 1 gram. And we have no way to store it. At present production, we might make billions of atoms of it every second, but it actually takes us years and years to accumulate just 1 gram of the stuff. That could change, and we could find a way to produce it and store it cheaply and efficiently and covertly, and that would make it the ultimate terrorist device. And this is sort of in the same vein as 3D printing. We're not going to do a separate section on 3D printing. Cool thing, wonderful marvel, but it does come with some attached concerns. In theory, when fully developed, you can produce anything at home if you have the template for it. So easy availability of this kind of thing like an antimatter or 3D printers that are able to produce destructive devices could actually make it impossible to maintain a technological civilization, because it just becomes too easy for individual lone members to damage that civilization, and we have no shortage of lunatics. This becomes a possible Fermi Paradox solution in the sense of a species having to take a step back because they just can't maintain technological infrastructure to support interstellar travel without constantly being vulnerable to their own crazy persons wreaking disproportionate destruction. Our last category, mind control, will ponder an alternative solution to that, but we have one other category first, and like antimatter, it revolves around very powerful energy sources. Suicide pact technology is essentially any technology that just by using it guarantees your destruction. Some people would say that things like the internal combustion engine or antibiotics or nuclear power or computers are these kind of things. The category in this video, though, refers more to a technology that looks too good to be true and turns out to be apocalyptic and unavoidable. You might remember some years back the concern people had about the CERN supercollider making a black hole that would sink to the center of the Earth and gobble up the planet. I'm not going to address all the flaws in that idea, but let's hypothesize someone invented some power plant that sucked energy out of seemingly nowhere for free. Unbeknownst to them, this really cool device sets off a ticking time bomb that blows the plant to smithereens a year after use, and in a way no one can foresee. It's just not predictable. If the physics allowing this device were almost impossible not to discover before space travel was really practical, like how you almost can't avoid discovering computers before you make orbital satellites, then every species figures it out, uses it, and blows themselves up before they can expand into the stars. And this is a total Fermi Paradox solution. Where there are other cataclysms, we can see it coming, right? We can see how potentially computers could be dangerous to us, right? Or potentially how nuclear weapons could be dangerous to us. And so it's possible that a species could see that and avoid that danger. This is a case where there's just no reasonable person who's going to look at it and be concerned, and so it sneaks up on you and blows you up. And again, some feel that computers or AI are an example of this, or fossil fuels or nukes, as we've been discussing throughout the video. But this concept of the suicide pact technology isn't a specific apocalypse, just the notion of a technology that unavoidably kills its users and unavoidably gets discovered soon enough to kill them. How plausible is this? Well, like any Fermi Paradox solution, we have to consider if it covers all the bases. We haven't discovered any technology of this kind of variety yet, and we really could build a moon base or a Mars base if we wanted to. Problem, probably even one that could keep going if it ceased to exist, so that's a little bit dicier. And other alien worlds might have their interplanetary neighbors be closer. They might have lower gravity or thinner air, and orbital launch is the real problem for early space travel to begin with. So if they have lower gravity or thinner atmosphere, they wouldn't have as much of a hurdle. So besides us having no real reason to believe there's any suicide pact technology, I mean that's the kind of the point of the stuff is you don't see it coming. We also don't know that other creatures, out there who could have reached our own technological level, which is clearly possible, might not already have a splinter colony on another world which would be protecting them from that kind of explosion that would take out their own planet. So even this isn't a really good Fermi Paradox solution. And it actually will get worse every year as we get further along in terms of our technologies. Our last category is mind control. As we mentioned in the antimatter section, you've got to worry inside a technological civilization about what crazy individuals can do, because they can wreak just so much vast damage compared to what one lone crazy person could do without technology on their side. One of the solutions to that, if you have the technology to do it, would be a total Big Brother state or even outright mind control. And certainly there's even more sinister reasons someone might want to use this sort of technology. Now, in of itself, this is totally relevant to the Fermi Paradox. It doesn't care if you've got mind-controlled species or not. Just like it doesn't care if they're genetic supermen or robots, it's only about whether or not they're an expansive, intelligent species. But the specific types of mind control could be a factor. For instance, a culture that's gotten burned by technology might use mind control to permanently lock technological progress at a safe level, a level that was too slow for interstellar travel. Or they might maintain an outright ban on expansion because they can't reliably maintain that enforced orthodoxy over light years of space and communications lag. They don't want any of their colonies to splinter off because, as far as they're concerned, that would be a threat that they'd have to deal with down the road. It's sort of like having to rule two islands at once. One of those islands is going to want to break free from the capital island, and maybe the potential threat of having that other island colonized is just not worth the risk for the resource it brings you. And interstellar space isn't a planet. Moving resources is a hugely long and hard process, so they might just not see a value compared to the risk of having an enemy at their doorstep. So any mind control or social control that results in motives not to expand and could be reliably enforced for millions of years is a valid Fermi Paradox solution, but only where there's a universal motive to do this, since it would have to be nearly all aliens doing this, and it would really only apply to where there was a clear suicide pact technology on the horizon. So there we go. In some way, we looked at the possible doomsday scenarios for what might take out intelligent life, and we see that there's not that many good fits, in terms of the Fermi Paradox, for things that would get most, let alone all, intelligent species. I hope you've enjoyed this video. Feel free to check out some of my other videos and leave comments below. Thanks for watching, and have a great day.